Okay, so we have a look at question 7. There's an AC generator. The coil turns at constant speed. Alright, so as the coil turns, you generate electricity. Right, draw an arrow to show the direction of magnetic field at point P caused by the poles of the magnet. Alright, so this is north and south. So clearly the magnetic field is from north to south. Right, so at P, direction is towards the south. Okay, so we have the output voltage of the generator measured with respect to time. Okay, the horizontal, the coil, figure 7.1 shows the coil horizontal with side X near the north pole of the magnet, right? So we have a look at the diagram. Side X is near the north pole. At this position, the voltage produced is shown as point A, right? So this is point A, where you have maximum voltage. Right, explain why an output voltage is produced. Right, this is a general question that links to Faraday's law. Basically, you have to mention there is a change in magnetic flux or magnetic flux linkage of the coil because the coil is turning. Alright, and there is a therefore induced EMF. Alright, so these are the two key points to discuss. Alright, state which point shows the voltage when the coil is horizontal with side X near the south pole of the magnet. Alright, so we know that A is when side X is near the north pole. So when I rotate 180 degrees, alright, when I'm near to south pole, alright, I should expect that I have completed half the period. So instead of A, I will be at C, right? So that's why I get C, right? So describe the position of the coil where it produced the voltage shown as point F in figure 7.2. Alright, so 7.2 refer to point F, whereas the voltage is 0. Okay, if you recall from your textbook that whenever the coil is rotating like that, alright, when the coil, this coil is vertical, alright, it will actually produce 0 voltage, even though it's cutting maximum magnetic flux. Alright, remember that the change in magnetic flux is what causes induced EMF. Right, the fact that it has maximum magnetic flux does not imply that the induced EMF is maximum, right? They are different things. Okay, again, if you're very confused, please refer to your textbook, page 431. Alright, so again, go back to your textbook, page 431, and have a look at the diagram there for better understanding. Right, so describe how an output current from an AC generator is different from a current produced by a battery. Right, so output current from AC generator changes direction every half a period, right, which is why it's called an alternating current. Right, whereas a current produced by a battery always flows from the high potential side of the battery to the low potential side of the battery without changing direction. Right, basically the battery, right, the high potential and low potential sides do not change. That's why the current direction does not change. For an AC generator, the high potential side and low potential side will keep changing. Right, that's why the current keep changing. Alright, so with that, yep, we're done with question 7.